The broadcast is now starting. All attendees are in listen-only mode.
Good evening, everyone. Good morning. So this is our fourth week of this batch. We have Azhar, Khurram, Manjunath, Raj, Ramakrishnan, Siva, Sai, Tony, Venkat. So, hi to everyone. I hope you guys had gone through and revised all the concepts that we have discussed so far. In today's session, we will start with our storage and content delivery options, and we'll start with the EBS or the Elastic Block Store, because storage is quite an important or the essential component of our architecture. So we have to see various storage options, and we will see our content delivery options at the cloud front. All right. Okay. So we'll start with the EBS or the Elastic Block Store. And in the meantime, let's see if we have some instances running, or we can just launch new instances from scratch. Okay, we don't have instances right now. So I'll just launch 1 or 2 instances, the Microsoft Windows Server based instances, so that we can perform our lab sessions on our EBS. Shiva is saying, I cannot see the EBS in storage. Shiva, I'll just let you know where you can see. Okay. Just give me 1 second over here. Alright, so our instances have been launched. Now, while launching the instances, I had chosen the 30 GB of root volume, or the EBS volume, towards these instances because those volumes are being attached automatically. Now, you can track the Elastic Block Store on the left side of this window, which says Volumes and Snapshots. On Instance Dashboard, just on the left side, you can locate the volumes and the snapshots. So these are the options of the Elastic Block Store. Okay, these are the options. Now, we'll discuss the theory first. We'll just go to the PPT slide, and then we will see that how to implement our volumes, how to expand the volumes, mount them, and also how to create the backups in the form of snapshots. So let's discuss our EBS or the Elastic Block Store. Now, what is EBS? EBS provides you the block level storage volumes for use with EC2 instances. So you can say that these are kind of virtual hard blocks or virtual hard drives that you attach or associate to your EC2 instances. EBS volumes are highly available, and they are reliable storage volumes that can be attached to any running instance that is in the same availability zone. So the EBS volumes and your instances should be in the same availability zone so that they can be attached or associated to each other. EBS volumes that are attached to an instance are exposed as storage volumes that persist independently from the life of the instance. Now how this works in such a way, let's suppose that this is your instance. This is your instance and this is your volume. Right? Now these two, even though whenever you open the volume, whenever you log into instance, right? For example, you perform an RDP or SS session towards the instance, you can see that these volumes will appear as C drive, D drive, root drive, any kind of drives on your instance. So this volume would be attached to EC2, and it will appear that both these two components are same, which means that you will think that this volume is in-house located into your EC2, like we have in our desktops. However, it's completely different at the back end. The reality is completely different. Even though your EC2 instances and the volumes, they appear as a single entity, at the back end they run on the separate pieces of hardware. For example, this EC2 instance might be running on an HP or IBM box, a physical host, and this volume is running on, let's suppose, NAS or SAN storage. Right? So even though they appear as same, however, at the back end they run on a separate piece of hardware, and these two components reside in the same AZ. You cannot associate a volume to an instance that is up and running in a different availability zone. So if you want to associate the volume to an instance, it is quite necessary that both these two components should reside in the same data center. Okay, so that's why this statement says, if you see the statement, it says EBS volumes that are attached to an EC2 instance are exposed as storage volumes that persist independently from the life of the instance. So the life of your volume, it's completely independent from the life of an instance, which means that if this is your volume and you have attached to instance, because they are running on a separate piece of hardware, even if your instance terminates, it goes down, in that case still you can retain the volume and you can attach it to any one of the instances running in the same availability zone. That's why we call it, we agree to the statement that the life of the volume, it persists independently with the life of the instance. So if the instance goes down, it gets terminated, it crashes, still your data is durable, it is secure. You can, because your entire data would be staying on the volume. Each and every bit of data would be stored on a volume. So if the instance gets terminated, there's nothing to worry about. We can attach that volume to any one of the running instances in the same availability zone, and we can retrieve our data. So this ensures that our data is secure, durable, and it is a reliable kind of storage. I want to use the EBS. What are the use cases where you have to use this EBS? First thing first, if the data changes frequently, if you think that your data is changing frequently and you need a quick access to your data, EBS is the best storage option for you. You will use EBS if you are looking for a long-term persistence, if you want the data to be durable and secure, and also you want the reliability of your data. So the EBS act as storage volumes, and these volumes can act as a file systems for databases, and also you can use that for I would say data warehouses or something like that, or for your backend applications. These database style applications that frequently encounter many random reads and writes across the data sets. So you have some kind of database style applications. In that case, you may encounter read and write operations across the data sets. Now, if you once we move forward, we will discuss this concept called IOPS. IOPS. IOPS stand for Input-Output Performance, which means that within a second, how much data or how much random read and write operations can be encountered or can be carried on a single piece of volume. Okay, we'll discuss in detail once we discuss the volume types. So once we just move further, also you can use your EBS for the throughput intensive applications that perform long continuous reads and writes. Now, Amazon Web Services, they have recently introduced two types of HDD or hard disk type of volumes. Those are called throughput intensive volumes, and the I would say it's a kind of a magnetic volume. It's called cold HDD. So throughput and the cold HDD. So these are the three type of hard disk based volumes that they have introduced in the recent past. So those are suitable for the throughput intensive applications. So let's do one thing. Let's go back to our management console, and as you can see that these are the two instances that are launched in front of you. These are Windows-based instances, instance A and instance B, and they both are running in different availability zones. Instance A is running in 1B, whereas my instance B is running in US West 1C. Now, if I just go to our volumes on the left side in the navigation pane, these are the two 30 GB. So each instance will have a 30 GB of root volume being allocated to it. You can see the volume ID of it. Okay, so I can say that this volume is from my instance A. So I'll just write it down. So this volume belongs to my instance A. Now let me just expand this. Okay. I'm not getting the option. Okay, this one. Now, and this volume on the top would be for my instance B, so that we can differentiate that which volume belongs to which instance. Now, we'll do one thing. We need to access the volume A and see that how it's being mounted. So we just go to the instance A, and we'll initiate an RDP session towards this instance. So let me open my Microsoft Remote Desktop application. As I was saying, for the feature account, is the EBS volume chargeable? Yes, Azure, because you get a 30 GB of volume for any given month, 30 GB. So if you exceed this limit, if you create an EBS volume more than 30 GB for any given month, then you would be charged for that. Okay. So right now, okay, and apart from that, there are two types of volumes that are being allowed: children purpose SSD and the magnetic. I'll let you know. So we'll see that what kind of limitations are being imposed on the feature. So let me just delete this connection, create a new one. I'll just name it as instance I. Copy and paste this public IP, and let me just go to the actions and click on get Windows password, and let me just choose a file to decrypt my password right now. So my username will be administrator. Now this is there by default. So I open my Microsoft remote desktop, paste this, go to my password section, just copy this one and paste it over here. And now we just log into our instance A. Let's wait, it will take some time to log into instance A through RDP. We're almost there now. Alright, so we are on our Windows Server 2012 desktop. I go to the start menu and I just type in run. And run window, I'll just type in disk mgmt .msa and press enter. Now this would take me to the disk management console of my Windows instance. And as you can see, that this is showing my 30 GB of root drive that's being allocated as a C drive to my Windows instance. If I just go to start menu and go to this PC, you can see that this is the 30 GB of root volume that's being allocated as C drive and showing up over here. So only 10.9 GB is free. The rest is taken by the program files and the OS files. Okay, you can see over here. Hang on one second, please. Okay, so this is our 30 GB of root drive. Now we can add more volumes to this instance, even though it's running. So right now we have a C drive. We can attach multiple volumes that can appear as a D drive, E drive, F drive. So we can attach as many volumes as we can, but yes, there are some restrictions that are being imposed on certain instance types. That's a different story. So right now we have this instance A. Let's see if we can attach multiple volumes to it. So on the left side, I go to volumes. And at the top, I can create volume. Now these are the different volume types: general purpose SSD, Trojan IOPS, magnetic. These two are the new one: throughput optimized and cold HDD. So these are the hard disk based kind of, you can say, new volumes that have been introduced. So let's go. I'll not go with the volume types as of now. Let's stick to the default one, which is general purpose SSD. So we'll discuss that, what these volume types mean. The volume size, I will just keep it as 10 GB as of now. Okay. And I have to ensure that the availability zone is US plus 1B, because my instance in which I'm logged in right now it resides in US West 1B availability zone. Okay. So the rest, all the options, I'll just keep it to default right now and click on create. So I just name this volume as secondary volume for my instance A. Okay. So that we can differentiate that this secondary volume is for the instance A. And you can see that over here it is showing as available on the right side. Let me just show you that. This one. It is showing as available, which means that it's not attached to any one of the instances as of now. So while this volume instance A, the secondary volume is being selected, I go to actions and attach it to the instance. Now you can see over here that I get the option to attach this additional volume to the instance running in the US West 1B availability zone. So I choose my instance A. It will automatically populate the device name, and I click on attach. Now if I just go back to my disk management window on the Windows Server, you can see that this is a 10 GB of unallocated storage that's been showing up over here. Even though if I just go to this PC, this 10 GB is not showing up over here because I need to mount this volume. First thing first, on the left side, I right click and click on online. Now it says not initialized. So I need to right click again and click on initialize the disk and hit OK. So after I put this disk to online mode, and to allocate this disk as a D drive, E drive, or F drive to my Windows Server 2012 instance. So while it's being selected, I right click on this one and click on New Simple Volume. Now this takes me to the New Simple Volume wizard. I hit Next. And this will automatically populate the size of volume. I hit Next. So you can assign the following letter. So I'll go with the D drive. Hit Next. Now I can format this volume using the default settings. Hit Next. And I click on Finish to complete this wizard. And you can see now that I have this 10 GB of additional volume and it's assigned as a D drive over here. So if I just open this PC again, you can see that this D drive, or the 10 GB of volume, it's being mounted successfully. So that's how we can add additional volumes while our instance is up and running. You can also add volumes when your instance is getting launched. So if I just click on Launch Instance right now and hit Select, and if I just go to the window where we add more instances, from here we can add more volumes. This you can do while your instance is getting launched. But you can also perform the same action after your instance is up and running. Okay? But you have to mount the volume even if you attach those volumes while launching the instances. Okay? Any questions, any doubts regarding this concept that I've shown you right now? So, Bajit, the question is it possible to extend the root volume with this additional volume? So, Bajit, from the Windows perspective, we can't extend the root volume, but yes, we can extend the additional volumes. I'll show you how we can do that. Right now, so Bajit, the question is that can we extend the root volume? I would say no. From the management console perspective, it's not possible, and also we don't get this option on the Windows Server 2012. But yes, we can extend, for example, our D drive, our additional volumes. Right now, this D drive or this additional volume is of 10 GB. I can extend it further to be of a 15 GB. Now, how I can go about doing that? I need to go back to the management console I go to the volume dashboard, and from here I can create another volume. So she was saying when we launch instance, we can launch only EBS, not instance store. Shiva instance store is also available, but not with all the instance types. But the reason being, the instance store is a temporary storage. Okay, if you stop and start instance, the data gets wiped out. So few instance types support the instance store, not all. For example, td.micro does not support the instance store volumes. Okay, so you have to see the list that what are the volumes that supports your instance store. So the higher kind of instance type like C3, R4, M3, M4, these kind of instance types supports the instance store. Raj, your question is when the root volume is full, how to increase the root volume, or do we have to create a new EC2? In that case, I would say, Raj, that if you are unable to extend the root volume, if you're not able to extend it, you can detach the root volume. So you can remove the instance. You can expand. So what you can do is that you can create a snapshot out of it. You can create a snapshot out of the root volume, and you have to launch a new instance while expanding the size of the root volume. So once we create the snapshots, I'll show you how you can go about doing that. Okay. So I click on create new volume again, and I will just choose 5 GB over here right now, and choose as my availability zone US West 1 Bay, and hit create. So I'll just name it as 5 GB. Five GB of additional volume that I will be assigned to my instance A. So I need to choose this one, go to actions, and attach it to the same instance again, and hit attach. So once I go back to the Windows Server 2012, I can see that this 5 GB is showing as unallocated, and it is showing offline. So I need to put it to the online mode right now. It's saying not initialized, so I just right click and click on initialize the disk, and hit OK. And now I need to merge this 5 GB of volume with the D drive. So I go to the D drive, right click on this one, and click on extend volume. Now we don't get this option on the root drive. If I just right click on the C drive, the extend volume has been grayed out. Okay. So for the additional volumes, I can extend it. I right click on this one and go to extend volume. Now it will take me to the extend volume wizard. I hit next. Add this 5 GB volume over here. Hit next and hit finish. So now I've merged the 5 GB with the 10 GB of volume. And if I just open this PC right now, you can see that now my D drive is a 15 GB of volume. The size of the D drive is 15 GB right now. So this is how I can extend my existing volumes by adding the volumes or attaching them from the memory console, and also I have to perform some necessary operations at the OS level. Okay. Guess we have some questions right now. Sure, we're saying, can we do multi-protocol? I'm not sure about that, Shiva. What we mean by that multi-protocol? Nothing I'm aware of. Okay. So this is how we extend our volume. The same in the same way, we can also shrink our volume. So if I just go back to our disk management on the Windows Server, I can right click and I can click on shrink volume to shrink the volume further. Okay. So this is how we can add additional volumes to our instances, mount them as additional drives at the OS level, and this is how we can perform the extension. Now we can also encrypt our EBS volumes. For simplified data encryption, you can launch your EBS volumes as encrypted volumes. Whenever you perform the encryption, the data stored at rest on the volume, the disk I/O, and the snapshots created from the volume all are encrypted. Encryption occurs on the servers that house your instances, providing encryption of data in transit from instances to the EBS storage. You can attach both the encrypted and the unencrypted volumes to a supported instance type. Now what happens is that, let's suppose that this is your volume. This is your EBS volume. Now you can perform the encryption. Now whenever you perform the encryption, anything that you store on this volume, each bit of data gets encrypted. The disk I/O, which means that all the input or output operations that carry on this volume, and the snapshots. We'll discuss the snapshots. Snapshots are the copies of your volumes. So they help you to create the backups of your volumes. So we'll discuss that. So all these things get encrypted automatically. And also, the data that flows in and out between the volume and the instance also gets encrypted. So if this is your volume, this is your instance, anything that flows in and out between instance and the volume, it also gets encrypted end to end. Okay, so encryption is an optional thing for you. It's up to you whether you go for it or not. Now the encryption is being done using a service called KMS, or Key Management Service. We'll discuss the KMS once we discuss our IAM, which stands for Identity and Access Management. So the KMS we use are either the default keys, default master key, or we use something called CMK, Customer Master Key. So once we discuss the KMS, we'll discuss how to create our own customer master keys from scratch. So right now, I will show you how you can perform the encryption. So once you go back to the management console, over here, if I click on Create Volume, just down below, you can see it says encryption. So I need to check mark this option, and it says master key. Now, if you don't have the master key created by yourself, you can use this default master key. Okay, it resides in the KMS, or the Key Management Service. So from here, you can select the default master key and click on Create. So your volume would get encrypted. So this is how you can perform the encryption on your EBS volumes. Okay. Now, not all the instance types supports encryption. This is the list that you can very well get from the AWS documentation that supports the encrypted volumes. For example, the T2.micro, it does not support the encryption. So let's summarize the EBS volumes. The EBS volumes are durable, block-level storage devices that you can attach to a single instance. It's a primary storage for data that requires frequent updates or storage for a database application. The volumes persist independently from the life of an instance. So even if your volume goes down or it gets terminated, still you can retain the entire volume and the data stored on that. An EBS volume can be attached to only one instance at a time within the same availability zone. So you can't attach the same volume to multiple instances. This kind of sharing is not possible. However, multiple volumes can be attached to the single instance. This we have already seen. So if you have a volume, it can be attached to only one instance at a time. Okay, you can't share it with multiple instances. And also, you can have multiple volumes attached to the same instance. Okay. Now there are three types of EBS volumes that we're going to discuss right now. The first one is general purpose SSD. Second one is provision IOPS, and the third one is magnetic. The two that I have been introduced afresh will not discuss that because there's not enough documentation available right now, and still it's not being used in the production right now as of now. But these are three options that we'll go for because these have been widely used, and we can see that how we can perform the IOPS operation, or we can associate these kind of volumes to our instance types. To start with, we'll discuss our general purpose SSD volumes. Now, SSD stands for solid state disk. Now, these are very high performing volumes as compared to the hard disk HDD. So we have SSD and we have HDD. It stands for solid state disk, and this is the hard disk. Now, SSD are very fast as compared to your hard disk. The operation of the SSD is being measured in the form of IOPS. This stands for input-output performance, which means how much data you can write on the volume within a second. Whereas for the hard disk, we measure its performance in the form of throughput. Okay, in the SSD, we in each IOP, for each I/O operation, we write about 256 MB of data, whereas for the hard disk, a single I/O operation, it facilitates 1024 megabyte of data. Okay, because the data sets are large in the hard disk as compared to the solid state disk. So solid state disk, it facilitates small amount of data to be written, but even though those are small and sequential, but it's quite fast. So over here, we will be using the SSD volumes that stand for solid state disk, which is being measured in the form of IOPS, the performance. Now, the general purpose SSD volumes, it offer cost-effective storage solution that is ideal for a broad range of workloads. For example, system boot volumes, virtual desktops, small to medium-sized databases, development and test environments. So it is for the medium-sized applications or databases or infrastructure, you will go with the general purpose SSD. You can also say that the general purpose SSD is the best volume for your buck. You get the best volume. It is one of the best and a consistent volume if you compare the prices as compared to provision IOPS. With the moderate, or I would say with the accountable pricing, you get the SSD volume with a very low cost. But you can't use this general purpose SSD with very high intensive database applications where you may encounter very high level of read and write operations. The volume size, it scales from 1 gigabyte to 16 terabyte. The maximum throughput is 160 MB per second. The baseline performance you get is only 3 IOPS per gigabyte. Okay, this is the baseline performance, and the maximum IOPS that you get is 10,000. This is the maximum that you can go up to, with the ability to burst up to 3,000 IOPS for volumes under 1,000 gigabyte. Okay, so 3 IOPS per gigabyte is just the baseline performance, and 10,000 IOPS is the maximum that you can get from the general purpose SSD. Now let's discuss our second level of volume, that's called the provision IOPS. Now this is, I would say, the costliest one out of all these volume types. It never comes under the free tier category and this is a very high performing kind of IOPS volume. So you will use the provision IOPS with a very high intensive or very large database applications where you may encounter frequent and consistent read and write operations. Ranga, already I've discussed the volume of the IOPS in the previous slide. IOPS stand for input output performance, which means that how much data can we read and write. We can read and write on the volume within a second. Okay, so it stands for input output performance. So the provision IOPS, it is designed to meet the needs of IO intensive workloads, particularly database workloads that are sensitive to storage performance and consistency in random access IO throughput. It is critical for business applications that require sustained IOPS performance or more than 10,000 IOPS or more than 160 MB per second of throughput per volume. The volume size scales between 4 GB to 16 TB. The maximum throughput you get is 320 MB per second. And it consistently performs at the provisioned level up to 20,000 IOPS maximum. It is double the value as compared to your general purpose SSD. In the general purpose SSD, we just get 10,000 IOPS maximum, but in the provision IOPS, we get 20,000, which means that we can experience or we can let double the amount of input and output operations to be carried upon the volume, which means you can expect a very high level of performance or double the performance from this provision IOPS as compared to the general purpose SSD. And also, as the name implies, you can provision your own IOPS under the 20,000 category. For example, if we just go back to our management console, over here, if I just click on create volume, and if I choose general purpose SSD, it will say okay, this is a baseline performance that you'll be getting, and I don't have any option right now to provision my own IOPS. I have to go for the baseline performance that I expect from the general purpose SSD. But if I just choose my provision IOPS, I can provision my own IOPS depending upon how much size of the volume I should have. So let's suppose if I choose, let's suppose 1 TB on the top, I can provision like, let's suppose 15,000 IOPS. So depending upon how critical your applications are, how many input and output operations you may encounter for any volume, in that case you can provision your own IOPS, but the maximum you can go up to 20,000. So as the name implies, you can provision your own IOPS under the provisioned, depending upon your requirement. Do we have a question right now? Tony, your question is, does these SSDs have any lifetime as normal SSDs available in the market? Tony, what happens is, there's no lifetime that's been given, any documentation that's been over here. But the thing is, whenever you create something volume, whenever you create any kind of volume, it's an SSD volume or it's a hard disk volume, a copy of it automatically gets replicated on another hardware. So if you have this volume created, the Amazon Web Services at the backend creates a duplicate volume for you. Why? Because this volume will be residing on a hardware. If this hardware fails, still at the backend, the Amazon Web Services will switch over to you automatically to the duplicate volume. Okay, so there's no any lifetime that's been given by the Amazon Web Services, but yes, at the back end, they replicate your volumes or data at the back end without even your knowledge, to ensure that even if the volume goes down, because the volume might be residing on a NAS or a SAN storage, if it goes down, it crashes. So at the back end, they will automatically switch over to you to the duplicate volume. Okay. Manjunath, your question is the IOPS are too low. High performance throughput is also. You're saying that IOPS are too low, high performance, or throughput is also. Manjunath, the thing is that we choose the IOPS in case if we the operations that needs to be carried upon, they are random or they can be sequential, but the size of our operations are very, very less, up to I think 256 megabyte. But we look for the throughput if we encounter or experience large amount of data sets, large and sequential data sets. So it all depends upon you. Manjunath saying IOPS in millions. I don't think so, Manjunath. There's nothing called millions over here. I'm not sure whether you calculate the IOPS in millions in the traditional model, but 20,000 IOPS is the maximum that we can get with the AWS. Might be it's not in the AWS, but I'm not sure about what's going on in the traditional model. Okay. All right. Magnetic volumes. Now, magnetic volumes in a real-time scenario you will never use for the database style applications. These are just used as a cold volumes. Cold means that you just store your data just for the archiving purpose. You don't access the data stored on the magnetic volumes too frequently because it's quite dull and very slow performing kind of volume type. So let's discuss that. Magnetic volumes provides the lowest cost per gigabyte of all EBS volume types. The use cases are, you can use for the cold workloads where the data is infrequently accessed, and also you will use in the scenarios where the lowest storage cost is important. So magnetic volumes is the cheapest of all. You will never use it for the database style applications because it's very slow. So you just store the data that you don't frequently access. It is just for archiving your data. The volume size is between 1 to 1 terabyte. Now there's a correction. Now it is 16 terabyte now. Previously you can create the magnetic volumes only up to 1 terabyte, but now it's 16 terabytes. The maximum throughput you get only between 40 to 90 MB per second, and you just get only average 100 IOPS with the ability to burst to hundreds of IOPS. So you can't expect any kind of consistent or best performance out of it. It is purely for the archiving or for the cold workloads where the data is not frequently accessed. Now, these volume types are quite important from the examination perspective. You have to understand one thing, that provision IOPS, it is costliest of all, and you never get it under the free to category. This is a sure shot question that comes up in the examination. I will show you that how they formulate the question in front of you. Provision IOPS never comes under the free tier category. Now let me show you that what things you get under free tier. Hang on one second, please. So if we just go back to our console, let's type in aws.amazon.com/ec2/pricing. Hang on one second, please. Okay, so over here you can see in the free tier you get 30 GB of Amazon EBS storage in any combination of general purpose SSD or magnetic. So in the free tier you get either the general purpose SSD or the magnetic plus 2 million IO with magnetic and 1 GB of snapshot storage. So you exceed this limit, then you'll be charged extra. And also, let me show the EBS pricing. So you have to pay for each gigabyte of data depending upon the volume type you have chosen, and that's of course that also the prices will vary if you change your region. Okay, so you have to pay for the volume types and also you have to pay for the snapshots. We'll discuss the snapshots. Okay. So this completes our volumes. The next thing that we have to discuss is the snapshots, because snapshot is a quite important thing for you to understand if you want to migrate your data between the availability zones and across regions. And also, it's a very efficient tool to back up your volumes. For the web instances, it's manual, but for the database instances, you can automate the creation of your snapshots. Okay. Any questions, any doubts before we can just take a small break of 15 minutes, and once we come back, then we can discuss the snapshots, because it will take another 45 minutes for me to discuss the snapshots in detail. Any questions and doubts? You can expect around 5 questions out of 80 from the EBS. So EBS is a very important topic. Any questions, any doubts before we can take a small break? I'm just pause for a few seconds and let me know if you have any questions. I think no questions as of now. So let's take a break for 15 minutes. Once we come back, we'll discuss the concept of snapshots. So the snapshot is far more interesting as compared to volumes. Okay, so let's take a break. Thank you. Welcome back. I guess we all people are back now. So we had seen the concept of volumes, and just to summarize what we have done so far, we had seen that how we can mount the additional volumes. So we have to create the volumes from the mapping console, attach them to the instances, and once we launch or we get into the instances, then we can mount them as additional volumes. We can extend our additional volumes. After that, we have seen the volume types, general purpose SSD, Trojan IOPS, and the magnetic. And also we have seen the use cases that in what scenarios we will use these volume types. Okay. So right now, we will start with the snapshots, the concept of snapshots. So what are the snapshots? You can back up your data on your EBS volumes to Amazon S3 by taking in point-in snapshots. Okay. What do you mean by this point-in snapshots, and how this Amazon S3 has come to this picture? What happens is, let's suppose this is your EBS volume. You can create the exact replica, the exact copy of it in the form of snapshots. You can say that the snapshots are the backup of your volumes. Okay. Now, at the back end, these volumes are being saved in the S3 bucket that we can't have access to or we don't have transparency into. But at the back end, what the AWS claims, or they say that these snapshots are being saved in your S3 buckets that are being completely managed by Amazon Web Services at the back end. Okay. So whenever we take the snapshot of the volume, it will be the exact copy of it, and the snapshot will save your data in the S3 buckets at the back end. Snapshots are incremental backups. What do you mean by incremental backups? Let's draw something and see that how these incremental backups exactly work. I'm just opening my Word file. For example, you have this volume. Okay, this volume, let's suppose it's a 30 GB of volume. Okay, and as an administrator, your job is to take the snapshots after a gap of each 1 day. Okay, so what it did is that on Monday, I'm sorry, something went wrong. Hang on 1 second, please. So this is your volume. It's a 30 GB of root volume, and what you did is that on Monday, that's the first day of your working day, you took a snapshot. We'll call it as snap 1. And this snap 1 would be exactly, so it will save the 30 GB of volume for the very first time. So it will be 30 GB. So as soon as you take a snapshot, the first snapshot, it will be the first snapshot of the volume on Monday, it will save the 30 GB of the entire volume, including the data in your designated S3 bucket at the back end. Now, after a gap of 1 day, which means on Wednesday, you took another snapshot. I'll call it as snap 2. Now, the snap 2 would not be the entire 30 GB of volume again. There's an algorithm that works on the back end, and it will compare that with respect to the previous snapshot. Is there a change of the data on the volume? For example, between Monday to Wednesday, there was only 5 GB of data that got changed on your original volume. So the snapshot 2 will only snapshot or copy over only 5 GB of volume or 5 GB of data into the S3 bucket. Let's move further. Let's suppose on Friday, you took a third snapshot, that is snapshot 3, snap 3. Between Wednesday to Friday, only 2 GB of data got changed on the original volume. So it will compare the previous snapshot, that is on snap 2. It will compare the volume. So after the snapshot 2 was taken, what was the change on the data on your original volume? So if it's 2 GB, it will copy over only 2 GB of data into S3 bucket. So 30 plus 5 plus 2 is equal to 37. That's why we call our snapshots as incremental backups. After your first snapshot is taken, it will only increment or it will copy over only the change in your data with respect to the previous snapshot. All right. Now, you can reverse this cycle. What happens is that from the snapshot, for example, let's suppose this is your volume. From the volume, you have this final snapshot created. From the snapshot, you can create a duplicate volume. So this is your snapshot. You can create a duplicate volume from the snapshot. So even though you call it as an incremental backup, if you're able to retain your latest snapshot, that's snapshot 3, so from snapshot 3, you created this duplicate volume. Even though you create the volume from the snapshot 3, it will copy over the entire data, including your snapshot 1, snapshot 2, and snapshot 3. So if you are able to retain your recent snapshot, if you're able to access your recent snapshot and you create a duplicate volume out of it, it will copy over the entire content back to the previous snapshots. So that's how the concept of snapshot work. Okay. Now, we just go back to the management console, and you can see that these are the additional volumes on the top. This one and this one that is created. Let's do one thing. I'll create a snapshot of this 5 GB of additional volume that I attached to my instance A. So either I right click on this one, or I go to actions and click on create snapshot. So I need to assign a name to it. So I just type in snapshot of additional volume. And I can copy and paste it in the descriptions. I just copy and paste the same thing over here. And now since this volume is not encrypted, the snapshot will also not be encrypted. So I hit create now, and this creates my snapshot. Now if I click on that, it will take me to the snapshot dashboard on the left side. Okay. So this is how we create the snapshot. So once we create the snapshot, it will copy over the entire contents, the data that's being stored on the original volume at the time when the snapshot was being created. All right. Any questions, any doubts? Regarding the snapshot? Kamesh is saying email volume also gets stored in S3? No. The volume stays on your NAS or SAN storage on the physical storage devices. Only the snapshots go to the S3 at the back end. And snapshots are not just restricted to creating your backups or the incremental backups. It's far beyond than just create the backups. Let's take an example. You have this instance A, and with this you have attached this volume A. These are residing in your availability zone A. Now you want to create a duplicate instance with the same kind of data. So what you can do is, you can create a snapshot. From the snapshot, you can create a duplicate volume, volume B, that can be attached to instance B, and they can be running in a different availability zone B. So you can say that the snapshot can help you to migrate your data across the availability zones. And it's not just the availability zones, across regions as well. You can migrate your data, you can create or restore the duplicate volumes between regions and the availability zones. Let me show you. So let's go back to the management console. I have the snapshot created. From the snapshot, I can create duplicate volumes. So while the snapshot is being selected, I go to Actions and I click on Create Volume. And once I select this Create Volume right now, I can. Now this original volume from I took the snapshot, it was a 5 GB size. It was the general purpose SSD volume, GP2. So once I create a snapshot out of it, I go to Actions and click Create Volume. I can change the volume type of the duplicate volume that I'm creating. I can increase its size, and also I can change its availability zone. So the snapshot helped me to migrate my entire volume along with the data, and also I can change my volume types, and also I can increase the size of that volume. So my original volume from which this snapshot was created, it was one in US 1B, but this duplicate volume with different volume type and different size can be restored in a different availability zone. So that's the power of the snapshot. Okay. Now after that, so we can see the snapshot can help you to change the volume type, the size, and you can restore the volume, a duplicate volume, in a different availability zone. Now, if you just right-click on the volume or go to Actions, just go to Copy, and this snapshot is residing in Northern California. I can copy over the snapshot to a different region. Let's suppose Sydney. And I click on Copy. So what happens is that this entire snapshot will be copied over from Northern California to Sydney region. Once it gets migrated to Sydney region, I can restore a duplicate volume and attach that volume to any one of the instances residing inside the Sydney region. Okay, so you can see that the snapshot can help you to perform the data migration across the regions. There's much more. You can also share the snapshot with different accounts. Right-click on the snapshot and click on Modify Permissions. You can share it with any AWS account. So you have to pull out the account number of any other account, copy and paste the account number over here, and click on Add Permission. So that different AWS account should be able to access your snapshot, from which he can create a duplicate volume and attach that volume to any one of the instances running inside his Amazon Web Services architecture or account. Okay. We have a question. Ramakrishna saying, can we copy the instance and run from VMware? I don't think so, Ramakrishna. It's not possible. Kuram, your question is, can you please clear more about snapshot? How the snapshot capture the changed data? Is it taking the backup of blocks or backup of the complete file objects? I would say, Kuram, that the snapshot is not nothing like that. It captures the blocks or it captures the file or objects like that. The snapshots are incremental backups. So the first snapshot that you create, okay? So the first snapshot, let me just open the Microsoft Word document again. So if this is your 30 GB of volume, right? The first snapshot that you create would be the entire 30 GB of data stored in the form of snapshot in your S3 bucket, right? Now the next snapshot, for example, snap 2 you create, whenever you create the incremental backups or the incremental snapshot, it will see that what's the change of the data with respect to your previous snapshot and the original volume. So between snapshot 2 and snapshot 1, there was only 2 GB of data that was changed on the original volume. It will only copy over only 2 GB of data to S3 bucket. So instead of adding 30 plus 30 in your S3 bucket, which is equal to 60, it is adding 30 plus 2, which is equal to 32. This gives you a tremendous benefit in saving the cost. Why? Because S3 you have been built for the snapshot, and also because snapshot you have to pay for additional charges for creating the snapshots. So you have to pay only for 32 GB of snapshot instead of 60 GB. Okay, so it's an incremental backup. Whenever you create the subsequent snapshots, it only copy over the change on the data with respect to the previous snapshot and the original volume. Okay. So Venkat, you're saying snapshot only clones the volume data. My question in the earlier session was how to clone the instance. So Venkat, I've already answered this question right now. If you want to clone the instance, the thing is you have to create something called AMI, the customized. I discussed that in the previous lecture. You create the customized AMI, okay? Plus you have the duplicate volume, and that's been achieved from the snapshot. So you have the AMI, you have the volume that you extracted from the snapshot that can help you to clone your instances. Let me show you right now how you can achieve that. If I go back to the memory console and go to my instance dashboard, I choose my instance right now, go to actions and go to image and click on create image. Now this image would be created. It will copy over the entire image of this instance, and it will copy over the entire data stored on this volume in the form of snapshot. Okay, so once you click on create image, I can show you right now, I have this AMI created, this one. Okay. Apart from creating the image of your instance, it will create the copy of your volume in the form of snapshot. Let me show you. So once you click on create image, it will copy over the image and the snapshot. You can see that this snapshot was created once I create this image. So if you want to create a clone of the volume of the instance, so you have to choose the AMI. So once you go to the instance and you choose the instance and click on actions, image, click on create image, it will create the image and it will copy over your duplicate volumes, the snapshot of the volumes. Now you just go to the AMIs on the left side go to Actions and click on Launch. From here, you can launch your duplicate volumes with exactly the same image and the same data. Okay. Kamesh is saying, how is it possible that volume is changing continuously read and write operations? Venkat, volume will not change any read and write operations. The applications will write on the volume. The application will perform the read and write operations on your volumes. Kuram is saying, whatever reduced to 25 GB, you can do that. It's up to you. But you have to be sure that the data that you have stored on the volume, it's being accommodated within that size. Ramakrishna's question is, the snapshot inside AWS cannot be migrated to any of the cloud service or any host, right? Ramakrishna, nothing I'm aware of. Might be it's possible, but it's not in my knowledge. I think the snapshots should be migrated to other cloud service providers, because if you want to migrate your architecture from AWS to, let's suppose, Microsoft, there should be some kind of provisions. But as of now, I can't recall if some processes or tools are available. I think some open sources like, I forgot the name of it, Tosca, some kind of open kind of sources can facilitate that, but it's possible. Kamesh, your question is, does AMI is equal to instance plus volume? AMI is not equal to instance plus volume. AMI is just an image. But what happens is, whenever you create the image out of the running instance, it also creates the snapshots of the volumes. AMI is image only. But whenever you create the image, a custom-based image on your own from the running instance, it copies over the image and it copies over the volume in the form of a snapshot. Kuram, your next question is, let me clear one more question. If the initial snapshot size is 30 GB, assume 5 GB data is deleted, then how the second snapshot knows the data has been removed, and what will be the size of the second snapshot? Okay, so you're saying that if you delete 5 GB of data, so in that case, how the second snapshot will get to know that the data has been removed, and what will be the size of the second snapshot? Okay, so in the case where you delete the data, it's quite obvious that the next snapshot that you create will not have that data that's been removed from the volume. Okay. In that very case, if you delete the data, okay, I don't think that a snapshot will copy over any new content, because you haven't made any change. Yes, it will make a note that this 5 GB of data has been deleted. However, the next snapshot that you will create, okay, it will not copy over any data to the S3 bucket. Kuram Singh, they say, I claim snapshot has 30 blocks. You can say that. Because the thing is, snapshot will only, any kind of incremental snapshot that you create, it just copies over the changes. So if you don't have, if you haven't added any data, you have removed that, it's quite obvious that it will make of it, note of it, but it will not copy over any content to the S3 bucket. Okay. So this completes a snapshot. Snapshots are quite essential for you to create the backups of your volumes, and also it helps you to migrate the data across different availability zones and the regions. And also you can create duplicate volumes and duplicate instances in your account. All right. And also, if let's suppose if you want to create a duplicate instance and duplicate account, once a snapshot gets migrated to a different account, he can just open his snapshot. He can go to actions and click an image from the snapshot as well. That thing can be also performed. Yeah. So this completes our Elastic Block Store or the EBS, which includes the volumes and the snapshots. Any questions, any doubts before we can just jump over to our S3? That stands for Simple Storage Services. I'm pausing for a few seconds. You can let me know if you have any questions right now. Do we have any link to perform demo? Kamesh question is. Kamesh, I think I need to check whether I have some document created. If I have any kind of document, I'll just provide you at the end of the session. I need to check. Okay. I will just check that at the end of the session. Any more questions? Any doubts? The S3, that's for Simple Storage Services. Okay. What is a Simple Storage Service? Amazon S3 has a simple web services interface that you can use to store and retrieve any amount of data at any time from anywhere on the web. You can say that S3 is an object-based storage or a web-based storage like we have Google Drive. It's the same kind of thing. It's not a volume-based, it's an object-based storage. Now, in the S3, we have a thing called bucket. Now, what's a bucket? A bucket is a fundamental container for data storage. You can say a bucket contains your entire data. So this bucket right now, this will hold the entire information that you want to save this in this one. So it acts as the fundamental container for data storage. Every object is contained in the bucket. Now, what is an object? An object is a piece of data that you upload into this bucket. So if this is your JPEG file, your PDF file, doc file, Excel file, whatever file it can be, you can upload it or save in the bucket. So this piece of data is called the object. And the container in which it's being stored, it's called the bucket. You can configure the buckets so that they're created in a specific region. One thing we have to keep in mind that your buckets are region specific. So if you create your bucket in the North California and you save any data in this bucket, the objects or the data would store or would be contained within the premises of that bucket or of that region only. You can also configure a bucket so that every time an object is added to it, the S3 generates a unique version ID and assigns it to the object. So whenever an object gets uploaded to the bucket, it gets a tag, a key value, so that it can identify that object at the back end. For example, you upload an object called photo/puppy.jpg, and the bucket name is John Smith. So in that very case, you will get the URL for that object in this kind of format. So for every object that you upload to the bucket, it generates a URL or a link for you to access. So whenever you click on this URL, you can access the object through the internet. Okay. So let's go back. I open the My Console, and under Storage and Content Delivery, we click on S3. Now, it says, welcome to Amazon S3, Amazon Simple Storage Service. Now from here, I can create a bucket. Now you can see the definition over here. It says a bucket is a container for objects stored in your Amazon S3. So I have to assign a name to the bucket. Now there are certain rules or certain guidelines for you to assign a name to the bucket. First thing first, if I assign a name to the bucket and it's being used by any other user in the system, this bucket name would not be acceptable. For example, I just type in test, I choose my origin and click on create. You can see the error message over here. The requested bucket namespace is not available. The bucket namespace is shared by all users of the system. Please select a different name and try again. So if any other AWS account holder has created a bucket with the same name, you cannot choose the same bucket name to create your own bucket. It's the same thing. Whenever you guys create any Gmail account, Yahoo account, if a user already has taken that same username, you can't go for that. So you can get the recommendations, okay, you can't use this same username, it already exists, please select a different one. It's the same thing over here. So the bucket name that you're trying to choose over here should be unique in nature. That's the first protocol that you have to keep in mind. Also, no capital letters allowed. Everything should be in small letters. No caps allowed. It can be alphanumeric. For example, test 007. No special characters allowed except hyphen. And let's type in S3. So it can be a combination of your numbers and alphabets. No special characters allowed except the hyphen, and everything should be in lowercase, and also your bucket should be unique in nature. So when you're saying bucket is region oriented, but the bucket name is unique across all AWS region. I would say the bucket name space is unique across all the AWS accounts. So it's not that the user who has chosen this bucket name is in Northern California. Might be he had chosen the same name in Singapore. So the bucket names are being accepted globally. Okay. So now I choose my Northern California as a preparation and click on create. So this creates my bucket named test007-S3. Let's go to our previous slide. Now in the bucket we can upload something called objects. Let me do one thing. Let me just upload the objects right now. So either I can just go to the actions and click on upload. I can also create the folders within this bucket. Okay. Or I just right click and click on upload, and I can add any file. Let me just check that. Okay. So I add this file to this bucket, It's taking time to. So once I add this file, okay, I can add multiple files by clicking over here. So once I upload the object, this piece of data that I'm trying to upload, it's called the object. I need to go ahead and click on Start Upload. So this will upload my image file to this bucket. It's getting uploaded right now. Just wait. Okay, it's been done now. So you can see my object has been uploaded. I can right click on this one and click on download. So it says please right click, and I just click on download over here, and this will eventually open another tab and download my content, this file that is uploaded it. Okay. So this is how we upload the objects. It can be any format, JPEG, doc, Excel, any format, because it doesn't recognize the format or the extension of your objects that you're trying to upload. I guess we have a question right now. So my question is, if the buckets are region specific, how the objects in it can be shared across regions like snapshots? Not sure if I get the concept correct. Subhash, you got the concept right. The buckets are region specific. Any data that is stored in a bucket is contained within the region. But yes, we can migrate it to the different regions using a concept called cross-region replication. So once we move forward, I'll discuss that. Okay? I'll discuss how we can perform the migration. So let's discuss our objects right now. Okay, let's do that. So objects are the fundamental entities that you store in the Amazon S3 bucket. It consists of object data and the metadata. Now, what's this object data and this metadata means? If you just go back to the Maven console right now, this thing, the actual JPEG file that I uploaded, it's the data. And while this object is being selected, I go to properties. The information associated to this object, for example, the name of this object, the size, and the image type, it's a JPEG file. These attributes, whether it's a name, the name of this file, the size of it, and the format of this file, these are called metadata. So it's a set of name value pairs that gets associated to your data once you upload it. Also, you can see the last modified date and time. So these are all details that get associated to your actual data. It's called the metadata. The data portion is opaque to Amazon S3, whereas the metadata is a set of name value pairs that describe the object. So your object is uniquely identified within a bucket by a key name and a version ID. Now this is quite important from the examination perspective. Please pay attention. You can store an infinite amount of data in the S3 bucket. So there's absolutely no limit that how much data you can store in a single S3 bucket. So if you take this bucket, you can put the infinite amount of data in this same S3 bucket. You can upload as many objects as you can. However, the condition is that the size of a single object that you're trying to upload to this bucket should not exceed more than 5 terabytes. Now, it's a very, I would say, exceptional thing if you have a single object, a single file, which contains a size more than 5 terabytes. If you have to break that file into different parts and then upload it to the S3 bucket. Each object can contain up to 5 terabytes of data. Okay, so you can store an infinite amount of data in the S3 bucket, but the condition is that the size of each object should not exceed more than 5 terabytes. And also with a free tier account, you get only 5 GB of data storage to your S3 buckets. Only 5 GB. Okay. Okay. So let's go back to our management console. And I just go to the buckets right now. Now, you can access all the buckets belong to the same region if you can pay attention right now. At the top right corner it says global, which means this is a global dashboard. You can see the buckets that belong to different regions on the same web page. Okay. So on the same dashboard I can access the buckets that belong to different regions. Now, each and every object that you upload in the bucket has some permissions. Let me show you right now. If I just go to the bucket right now, I can set the permissions for this this object. So once I choose this image file, I go to Properties, and I go to Permissions, and I can click on Add More Permission, and choose everyone over here, and click on View Permissions, and Open or Download, and hit Save. So once I refresh the page right now, you can see that the link over here, it will have a different symbol. So let's run again. So anyone which has the access to the URL can access my content. So if I just open another browser right now and paste it over here, I should be able to access this content across the internet. If I copy and paste this for you as well, you should be able to get access to this JPEG file. You can try this one out. Okay. So how to make it public? Let me show you again. You choose the object, go to Details. Go to Permissions, and once you add the permission, you have to choose Everyone, and you have to choose that what kind of permissions you want to add. Right? So we can apply the permissions at the individual objects level. But what about if I want to apply the permissions to all the objects contained in the single S3 bucket? Because let's suppose if I have, 1,000 objects saved over here. If I go ahead and try to change the permissions at the individual object level, it would be a cumbersome task for me to do. So I can apply the permissions at the bucket level as well. So I go to the bucket dashboard, and while my bucket is being selected, I go to Permissions. Now this is my account ID, aws.lambda. Now if I click on Add More Permissions, I can choose Everyone, which means any person across the internet can access all the objects in my S3 bucket. Any authenticated AWS user. Now we will discuss a concept called IAM. This one. Through that, you can authenticate different account holders to access your S3 buckets. So once we do the IAM, we'll discuss that. Log delivery. Log delivery means that once you enable the logging, this service can put the data to your S3 bucket. We'll discuss that. Me is my account, and this is my account ID. So I can allow different people or all the people across the internet to access all the contents in this bucket. Either I just go to the individual grantee level and I apply the permissions, or I can apply something called bucket policy. Over here, under your provisions section, you can see this tab called Add Bucket Policy. Bucket policy is an effective method and tool to apply the permissions on your bucket to all the grantees in one single go. So let me show you how you can generate a bucket policy. You go to Add Bucket Policy over here, and right now, as you can see, this bucket policy is completely blank. At the bottom left-hand corner, where you can see AWS Policy Generator, this one, you need to click on that, and this will eventually take you to a Policy Generator web page. Over here, it's getting updated right now. We have to accomplish or complete these 3 steps to generate a code or the policy from scratch. In step 1, it says select policy type. So I would choose S3 bucket policy because I'm creating the policy for my S3 bucket. Now we have to add the statement towards our policy. You can see it says a statement is a formal description of a single permission. So each statement describes your single permission. Now, what kind of permission it should be? It should be allow or deny, which means the permission that you're trying to create right now, it will allow an action or it will deny an action. In our example, I would say deny. In the principle, I would choose as star. The AWS service will be selected as S3 by default. In the actions, these are the different actions that I can deny depending on the effect that I've chosen. For example, I want to deny the following action. Let's suppose delete object. I don't want anyone to delete the objects from my S3 bucket. So I choose, or let me just choose this one as well, delete object version. So these are the 2 actions I want to deny depending on the effect I've chosen over here. Okay. And now I have to apply something called ARN, that stands for Amazon Resource Name. What's that? See, the thing is that the Amazon Web Services, they recognize the resources through ARN. Now, if I just go back to the PPT slide, this is the format of the ARN that you have to select or you have to use. I'll copy this one. I'm sorry. I copy this one and I paste it on the WordPad file. So what's happening? Let's copy this entire thing again. I paste it over here, and now instead of example bucket, I have to type in my bucket name, test 007-S3. I'm sorry. And now I copy this entire ARN, go back to the Management Console, and paste it over here. Okay. So once I'm done, I click on Add Statement. Now this will add the statement to this bucket policy. Now I can add multiple statements to this policy I'm just going to create right now. But as of now, I'll just go with this one statement, and in the step 3, I'll go ahead and click on Generate the Policy. And this is my policy document. In the JSON format, it stands for JavaScript Object Notation. So I copy over the entire content and go back to the Management Console and paste it over here. and hit save. Now, as per this bucket policy, no one should be able to delete the objects and the objects versions. Now, you might be wondering that myself, which means my account, has a delete permission. I should be able to delete the objects. But if I go back to the object and try to delete that, most likely I should receive the error message. You can see over here. Why? Because if any kind of policy I define, it overrides all the individual permissions. So just go back to the buckets right now, go to the properties. So in the bucket policy, I've applied that no one can delete the objects. So even though I have the permission, this bucket policy will override. It will override the permissions that I've applied at the individual user level. Okay. So that's how we apply the bucket policy. This is not important codes configuration, so let's move forward now. Static website hosting. Now you can use your S3 buckets to host your static website. You will associate this endpoint to your domain name, but I will just show you a small prototype that how you can house a static website using your S3. So I scroll down and click on Enable Website Hosting, and in the index document, I just type in index.html, and the error documents type in error.html, and hit save. So I define my index and the error documents, and hit save. So once I do that, I open my bucket and create and upload my index and error document. So let me just open my text editor. Hang on here, please. And I can just create a new document. And I'll just type in the following text. Hello world. This is the home page of our website, okay, that is being hosted on S3 bucket. Okay, and let me just increase its font size and the color. Now I save this as my index.html document. And hit save. And now I create a new document that would be my error document. I'd say 404 page not found. Please try again. And I just increase its font size, the color, and I save this as my document in the form of .html. Save. And now I upload these files to these documents to my S3 bucket. Click on Start Upload. Okay, so once it's being uploaded, I need to go back. I go to Properties. I right click on this one and go to Properties. Okay, so you can see that I've defined my document right now. And hang on one second, please. All right. Why is that option? Hang on one second. Okay, so I need to create a new policy for it. Okay, so I have this sample policy. I copy this one, go back to my bucket, and I change its bucket policy. It assumes that I have to change this bucket name. Now this bucket policy will allow all the users across the internet to access all the contents in my bucket. Okay, so I hit save now. Now if I just go to the properties right now and go to static website hosting, so this endpoint, through this endpoint, I should be able to access my website. It is taken to the home page. If I give a / and type in something gibberish and press enter, it will say 404 page not found. So I'm copying over this URL for you. Please try whether you're able to get to the website or not. I will give you a kind of an assignment through which you can host a web page on S3 at the end of the session. So please try whether you're able to get to the web pages or not. I'm just pausing for a few seconds. Okay. Okay, it works for you. Fine. Good. Thanks for confirming. So this is how we house a static website on the S3. This is a prototype. Okay. You can have a full WordPress site hosted on the S3. It can support your static websites, not a dynamic one. Now we'll skip the logging version as of now. Subhajit is saying, is it possible to change the string via Route 53? Yes, Subhajit, it's quite possible. So if I go back to my Route 53 right now, I'm not sure whether I have the hosted zone created or not. I don't have that, but we create a hosted zone right now. Hang on one second. For example, add to lambda.in and create a public hosted zone. In that case, I can create a record set where I can go to alias, and this will eventually just show me as S3 website endpoints. It's loading right now. So I can choose the S3 website endpoints and route my domain's traffic to the S3 endpoint. We can do that. Okay. Kuram is saying static website is also working for me. Thank you. So that's how we host our static websites. I'll give you the documents through which you can host a web page on the S3. Okay. Let's go back. All right. Now once we select the bucket again, go to properties. We're not go to login events. It's not quite important. The versioning is important. We'll discuss that. What's a versioning? Versioning is a feature that allows you to preserve, retrieve, and restore every version of every object stored in the bucket. It provides an additional layer of protection by providing a means of recovery for accidental deletions and overwrites. Overwrites or explorations, I would say that. You can use the lifecycle rules to manage all versions of all your objects as well as your associated casts. Versioning-enabled buckets store all the versions of your objects by default. Once enabled, the versioning cannot be disabled, only suspended. Now, if we just go back to the memory console, we can enable the versioning on the bucket. So we click on Enable right now and hit OK. So this enables the versioning as my option. Now once I go to my bucket right now, after enabling the versioning, these two tabs on the top appear automatically. Versions, hide and show. These one. Now what's the relevance of these tabs? If I go to the show version right now, you can see that the version ID is null over here because the versioning was enabled after I uploaded these objects. Let me do one thing. Let me upload the same file, not with this one again. Hang on one second, please. I upload the same file again and click on Start Upload. Right now it's uploading. Actually, I have a 1.5 MB of file depending upon how much upload speed you have. Right now, I'm taking the webinar session, so the upload speed becomes lesser. All right, so now I uploaded this object. It automatically generates a version ID for this object automatically. Let's upload this image again. I right click, click upload, add file, and let me upload the file again. So every time you upload the same object again and again, it will generate a unique version ID for each version of the object that you upload to the same S3 bucket. Now I will show you what's the importance of the versioning as of now. I'm just waiting for the second file or the third version of this file to get uploaded. Okay, now you can see as soon as I uploaded that, I got a second version ID. Now what's the relevance of this version ID over here? Why you need to do, why it's important? What happens is that with each version ID, you can see the timestamp. The first one I uploaded on 10:25, the second one on 10:55, and third one on 10:56 p.m. Now, if I just go back to if I go to hide version on the top, and in the hide version, I select my object, right click, and I delete it. It's gone. But if I go to the show version, I can still retain the versions of that object from here. I can go to any one of the versions. For example, I go to 10:55 version, right click and download and retrieve it. So in case of accidental deletions, you can retrieve the version of the object depending upon the version ID and the associated timestamp. Also, if you overwrite accidentally, because for example, let's suppose it was an Excel sheet, and if you overwrite, so you can go back to any one of the versions of the Excel sheet or the Excel file or the spreadsheet, and you could download and retrieve it back. So that's the usage, or that's the advantage of the versioning. It helps you to retrieve the objects in case of accidental deletions or overwrites. Let's go back. Now, there's a concept that I want to discuss right now. Once you right click on this S3 bucket and click on upload, and you add the file, before you can add the file, by clicking on start upload, go to set details. Now, these are the different storage classes of your S3. By default, the standard storage you can see over here, where I'm just drawing this arrow, this is the default option or the default class of the objects when you upload them to the S3 bucket. Now, what's the difference? What happens is that AWS says, they claim that whenever you store a piece of data called object to the S3 bucket, at the back end, this object, a piece of data, gets replicated multiple times. Let's suppose 10 times. It gets duplicated to different S3 buckets, to different physical servers in the same region. Why? Because this S3 it resides on your SAN or NAS storage, might be, and if it crashes, still you can retain your data. This ensures that your data is secure and it is durable. Now, these storage classes that are mentioned over here, this describe that how many replications you get. The first one, that's called the standard storage. It gives you the maximum amount of replications. But yes, if you go with the storage class, this is costlier. The other two classes of the storage are less expensive, but you get lesser number of replications at the back end. Now, there is no documentation that supports that how much replication is there. I'm assuming for the standard storage, if it's 10, for both of these, it can be 5. The first one is called standard infrequent access storage. The second one is called reduced redundancy storage. The difference between them is that the only difference is that the maximum size, the minimum size of each object over in the standard infrequent access storage is 128 KB. That should be the minimum size of your object. So in the standard infrequent access storage and RRS, the standard for reduced redundancy storage, you get the lesser number of replications at the back end, and it's quite obvious that you have to pay less price because the number of replications are much lesser as compared to the standard storage. Okay. She was saying you download the file, but I cannot see that it's retrieved, the one you deleted. Shiva, the thing is that if I go back to my bucket, it's not showing up over here, right? If I go to show version over here, it's still over there. I can download it and I can put it back to my S3 bucket. That's how I'm retrieving it. Okay? Now we'll discuss the storage class that's called the reduced redundancy storage. Now, this word redundancy, it's very hard for me to pronounce, so I'll use it RRS in the short form. So, this RRS enables the customers to reduce their costs by storing non-critical, reproducible data at lower levels of redundancy than Amazon S3 standard storage. So the amount of redundancy that you get from this RRS is lesser as compared to the standard storage. And the data that you store in the form of RRS should be not critical, which means less important, and reproducible, which means you can generate it from any other source. RRS option stores objects on multiple devices across multiple facilities, providing 400 times the durability of a typical disk drive. Even though the RRS is not as much durable as compared to the standard storage, still the AWS claims that you get 400 times the durability of a typical hard disk that you use on your computers. It does not replicate the objects as many times as the standard S3 storage. and thus is even more cost effective. It provides 99.99% durability of the objects over a given year. The durability level corresponds to an average expected loss of 0.01% of objects annually. So these many percentile of the objects you may lose for any given month. So this thing you have to keep in mind. Okay. Now if we just go back to the management console right now, and just go to the properties of the bucket right now. Under the versioning, we have something called lifecycle. Lifecycle is a kind of a set of rules that help you to manage all the versions of your objects, the current version and the previous versions. So I click on add rule over here. It says choose a rule target. I click on configure a rule. I think there's something wrong with the format. I click on add rule again. It says, do you want to apply this rule to the entire bucket or to a folder? For example, let's type in images. /, which means I want to apply the rule to the folder stored in the S3 bucket. But I want to apply this to the entire bucket as of now. So therefore, I choose a bucket and click on configure rule. Now I can apply this rule to manage my cost with respect to my S3 bucket. Why? Because S3 is a costly option. It's not that much cheap. So now this is a new option. I'm not sure what it's all about, but it's not that much necessary. You can apply the actions either on the current or the previous versions of your objects. For example, you have created multiple versions of the objects in the S3 bucket. You can say that I can perform the transition of the older or the previous version of the objects from the standard to the infrequent access storage class after suppose 30 days, because this is less costly. Or I can archive my previous versions of the objects to a less costly storage option called Glacier. Now Glacier is less than half of the price of your S3. I think it's 1/5, but it's quite slow. Not that much efficient as compared to the S3. If you want to archive the previous version of the objects, let's suppose after 90 days, you can apply this rule on your previous versions. Or you can permanently delete the previous version of the objects after, let's suppose, 100 days from the bucket. So through these rules, you can help to these rules can help you to manage your cost, to bring down your cost for your S3 bucket. Okay. Cross-regional application. What exactly it is? Now this is the last option for this day for the S3 bucket. After that, our S3 bucket will be completed. Cross-regional application means you can replicate the objects stored in one bucket to another bucket stored in another region. For example, we have this bucket. Let's do that. We have this bucket that we managed to create in Northern California. And we have another bucket that we have created in North Virginia. Now this North California bucket acts as my source bucket, and this North Virginia acts as my destination bucket. I want that if someone stores or uploads the piece of data called object to the S3 bucket, it automatically gets replicated over to my North Virginia bucket, which is my destination bucket. This is called the cross-regional application. So I go back to my cross-regional application feature. Now, before I can do that, let me create, now this bucket I just created in my California, okay? So I create a new bucket, test 007-S3-VIR, which means that I'm creating that in my North Virginia, US standard. Hit create. The top bucket is in Northern California. This one, if it is go to the properties right now, you can see that it's been created. It has been created in the Northern California, this one. And the new bucket that I have created, this one, it is in the US standard or Virginia. You can see over here. Okay. Now, this top one, California, would be my source bucket. This North Virginia would be my destination bucket. Okay. So I go back to the, so I need to enable the cross-river application from the source bucket, which is my test 007S3. I go to the properties right now, and I scroll down, go to the cross-river application, click on enable cross-river application. It says select a destination region. I would say US standard. Select a destination bucket. I would say test 007S3VIR. And now it says that do you want to change the distance storage class? I would say I will give it a same. Now, to facilitate this kind of application, I have to create something called IAM role. Now, I will tell you the relevance of IAM role once we cover or discuss the IAM. So I just click on this one right now. It will automatically create a role at the back end so that this kind of application can happen properly. It's taking its time. Okay, you say click allow to give S3 application access to resource in your account. This is the role document, the policy document. I click allow, and this creates my role, this one, and I hit save. So this is how the cross-regional application. Now I forgot to tell you one thing. Both the source and the destination bucket should have the versioning enabled. Otherwise, the cross-regional application would not be possible. So I just go to I need to go to the bucket right now and save that configuration. So now I go to my destination bucket, go to the properties right now to enable the cross-regional application. I'm sorry, enable the versioning. So both the source and the destination bucket should have the versioning enabled. Thereafter, you can enable the cross-regional application. So I go to my source bucket, go to the cross-regional application again, enable it. I choose the destination region, destination bucket, and I click on create IAM role again. Hit allow and hit save. So now the cross-regional application is being enabled. So if I store anything in my Northern California bucket, which is test 007-S3, the contents will be automatically copied over to the Virginia bucket, which is test 007-S3-VIR. You can't copy over the entire bucket, but you can copy over the contents, the objects. So this completes RS3. Any questions? Any doubts? See, the use cases of S3 are it is used for the static website hosting. Also, it is used for the content delivery. I will, once we discuss the CloudFront, I will let you know what we exactly mean by the content delivery. But these are the common use cases for the S3. Any questions, any doubts? Let me see if I can give you the assignments for today. For the EBS, I'll give you an assignment how you can restore the EBS volume from a snapshot, a very small document, just of 2 pages. And I'll give you another document this one, to host a static website on your S3 bucket. You have to use this script, this code. Okay. And I think I have one more document, how to initialize the volume on your Windows. So these are the 3 documents I'll provide you. Copy this one and go back to the Adrika 30th July batch in the assignments. Today is 7th session. I paste all these 3 items for you. So you will get these items after few seconds or few minutes. It will get some time to get uploaded on the Google Drive. Okay. Chrome, your question is, once we enable cross-run application, that it will work for the future objects, or it will start copying the current objects. It will only work for the future objects, not the current objects. So right now I enabled this cross-run application. Starting from now onwards, I copy over any object. If I put any object in the source bucket, it will automatically copy over the content to the destination bucket. It will never look into the current objects. So the versioning gets enabled after the objects would be copied over after you enable the versioning. So the question is, source and destination bucket might have different permissions, so it might be same also. I would say, Subhajit, permissions can be different, but it doesn't matter. So that's why we create something called IAM role, because we are giving this permission at the backend. Okay. So I've given you the assignment for today. You have to do 3 assignments. The first one is how to initialize the volume for your, once you attach the volume to your Windows instances. One is for hosting a static website on the S3, and the other is for restoring the snapshot and EBS volume from the snapshot. So these are the assignments for you to perform today. Tomorrow we'll cover our Glacier, import export Snowball, and storage gateway. So this will, and if the time permits, we'll also cover our CloudFront. So tomorrow we'll be covering or completing our storage or content delivery options. All right. So that's it for today. Any questions, any doubts before I can wind up, or we can wind up? Kamesh is saying, do we have to get a DNS to test Route 33 or any other way we can do practical? Kamesh, unfortunately, there's no any free DNS service available. You have to buy on your own. Okay. So either you can buy from the AWS, you can get a .com domain for $12 per year, but I would say that there's no need to do that as of now. But if you want to get into the in-depth that how it's working, then you have to buy a domain. Otherwise, you can just create a hosted zone and see that how you create record sets and so on. Yes, Kuram, what's your question? What is the expectation from the exam perspective? That's the question from Kamesh. Kamesh, the thing is, the expectations from you from the examination perspective is that you should be well aware as an architect how to create or structure your VPC, and you should be very well aware of the fault tolerant features, including load balancer, auto scaling, and you should have a sound familiarity with these storage and content delivery options. Now, if you want to see the detailed level of that, what are the exact expectations, I would highly encourage that go to the following website, aws.amazon.com/certification. Once you go to this website, just choose or go with the AWS Certified Solution Architect Associate. Once you go over there, you have to go to this link which says click here to review the full details in the exam blueprint. Over here you can see exactly the topics or the contents or the expectations from you from the examination perspective. Okay, so this contains the entire blueprint, that what kind of questions are being there, what kind of topics come up. You can see over here. Okay, you can see IAM, VPC, S3, EC2, EBS. Okay, we'll discuss the import export snowball, storage gateway, Route 53, we already discussed that. So you can see over here. Okay, I'm copying and pasting this link for you so that you can go through it. Kuram has a question, I guess. You're saying, as you mentioned, that the first snapshot will be 30 GB. Snapshot will cover the changes. I checked the second snapshot, it's also 30 GB. As per your words, the next snapshot should be a 0 GB. Because no data added or removed, please clarify the ambiguity, thanks. Kuram, the thing is that the snapshot would show up as a 30 GB. Even though if you haven't changed, but at the back end, it will save 0 GB in the S3 bucket. Even though it appears in front of you that the second snapshot that you're creating is exactly of the same size, that is 30 GB, but at the back end, it is storing 0 GB of data in the S3 bucket at the back end. That's why I created the drawing and showed the S3 bucket. So even though it will appear as that it's 30 GB of data, but at the back end it will be saving as 0 GB. So in that case, you will not be charged additionally for that snapshot storage. Okay? Because on the back end, it's not storing any data. At the front end, it may appear to you that it's storing 30 GB. I hope this answers your question. Because the S3 bucket that's working on the back end, we don't have any transparency or access to. So the back end, the S3 bucket will not save any data because you haven't made any change. So you'll be charged only for 30 GB, not 60 GB. Even though it may appear that you have 60 GB of snapshot created. Kuram is saying how to check the front end snapshot size. I would say, Kuram, you can, if you want to. The thing is, at a snapshot from the AWS perspective, it's showing you as the entire 30 GB. But you can't see the front end. I'm not saying what you exactly mean by front end snapshot size. It will depend that how much data has been saved in that snapshot. What you can do is you can retrieve a duplicate volume for the snapshot, attach that volume to the instance, and once you log into the volume of the instance, you can see that how much data is being stored over there. that you can do. Okay. Yeah, thanks. You're welcome, Kuram. So thank you so much, guys, for your time and patience. I appreciate that you spent 3 hours with me while discussing all these important concepts. Tomorrow we'll meet at the same time, same place. That's GoToWebinar. And last but not the least, after the session gets over, please fill in the feedback form, because it's quite important for me to showcase to the higher management. It's a kind of a report card that I want to show, or I should show. So I'll highly encourage that after the session gets over, just take out a single minute of your valuable time and fill in the feedback form. So let's meet tomorrow. All right, goodbye, bye-bye.